Yeah, good afternoon, online students. Rajeshwari, Sashmin, Lakshmi, Subbalakshmi, Shreyas, Priyasha, and Deepika.
Good afternoon, ma'am.
Good afternoon,
Good
and good afternoon, children. I'm extremely sorry, so I'm late by half an hour. So I'll finish only at 4:30. Okay, I'll text in the group. Students here in the class, I'll text in the group. We'll finish only at 4:30. I hope you've all finished dinner. I'm sorry, lunch. Okay, so we were supposed to have the class from 1:30 to 4. So since I'm starting at 2, it will be from 2 to 4:30. Online students. Okay. We'll start with real numbers. I told you today's session will be exclusively on real numbers and similar triangles. Let's get started with real numbers. Write on the question, children. பின்னாடி இருக்கு ஃபேன் ஸ்விட்ச் பின்னாடி இருக்கு. Done writing this, children? So the total distance around the circular field is 360 kilometers. The first cyclist or cyclist A covers 48 kilometers in 1 day. Cyclist A covers 48 kilometers in 1 day. So then how many days will he take to complete this total distance of 360 kilometers? So 360 by 48, 15 by 2 or 7.5 days. Similarly, cyclist B would take 360 by 60 kilometers because he is able to complete 60 kilometers or he is able to cover 60 kilometers a day. So number of days cyclist B would take to cover 360 kilometers is equal to 360 by 6. 60 kilometers in 1 day. 360 kilometers, how many days? 360 by 60, 6 days. And cyclist C, 360 by 72 because he covers 72 kilometers in 1 day. 72 kilometers in 1 day. So how many days would it take to cover 360 kilometers? 360 by 72, 5 days. Now we have to find, see, now as we have discussed this concept of LCM and HCF earlier. When you're expecting you have to expect the answer, meaning whether the number is going to be greater than the given numbers or smaller than the given numbers. All right. So you should have that expectation of the answer. Are you looking for, now the numbers we have in hand are 7.5, 6 and 5. The numbers we have in hand are 7.5, 6 and 5. Are you looking for an answer which is greater than these three numbers or smaller than these three numbers? Will they meet in less than these days? 7.5, 6, 5, less than these days, or will they meet after 7.5 days? No, see, they may not meet when they cover one, one round. What kind of an answer are you expecting? More than 7.5. More than 7.5. See, a circular field has a circumference of 360 kilometers. 3 cyclists start together and cycle 48, 60 and okay, I understand your doubt. Now we assume that they stop after covering 360 kilometers. No, they keep going. They keep going till they meet. They keep going till they meet. The thing is, in 7.5 days, the first cyclist covers 360 kilometers. In 6 days, the second cyclist covers 360 kilometers. And in 5 days, the third cyclist covers 360 kilometers. They go on like that. So when will they meet? When will they again meet at the point where they started? More than 7.5. So you're supposed to find the LCM of these three numbers. Find the LCM of 7.5, 6 and 5, which means we'll have to find the LCM of 7.5 is nothing but 15 by 2. So let's write it as 15 by 2. Let's write this 15 by 2. So we have to find the LCM of 15 by 2, 6 and 5. Now, how will you get rid of 2 from the denominator? Listen, children. How will you get rid of 2 from the denominator? Multiply by 2. Multiply all the three numbers by 2. So you get 15, 12 and 10. Now find the LCM of 15, 12 and 10. So what is how do you express 15 as a product of its prime factors? Yeah, let's do that. So 15 is equal to 3 into 5. 12 is equal to 2 squared into 3 and 10 is 2 into 5. So how do you write the LCM of these three numbers? 15, 12, and 10. You'll have to write all the prime factors once. 2, 3, and 5 once with the greatest power you see, correct? The prime factors here are 2, 3, and 5. Write all the prime factors once and raise them to the highest power. The highest power of 2 you find is 2. Nandini, any doubt there? Yeah. The prime factors we see are 2, 3, and 5, correct? The highest power of 2 is 2. The highest power of 3 is 1. And the highest power of 5 is 1. So this is it. So this is 15 4s are 60. Now the required number is not 60. Required number is equal to 60 by 2 because we multiplied all the numbers by 2, right? So now divide the answer by 2 to get the correct number. See, for the sake of convenience, we multiplied when you find the LCM of 7.5, 6, and 5, it is 13. But we wanted to make the numbers convenient. So we got rid of the denominator 2 by multiplying. See, supposing the denominator was 3. Supposing the denominator was 3, you would multiply by 3. Supposing one had the denominator 3 and another had the denominator 2, then multiply by the LCM of 2 and 3. You want to get rid of the denominators. If supposing one number has a denominator 2 and another number has denominator 3. So if you have denominators, basically find the LCM of the denominators and multiply the numbers with the LCM. And find, multiply the numbers with that with the LCM of the denominators, and then find the LCM of the three numbers. Once you get that answer, divide by the number you had multiplied by. You had multiplied by the LCM, right? Divide by that now. So that's what we're doing. So we multiply by 2 everywhere, right? So the answer we divide by 2. So 30. So the cyclists will meet together after 30 days at the starting point. After 30 days. In 30 days, the first cyclist would have gone 4 rounds. 7.5, 7.5, 7.5, 7.5. In 30 days. Because he needs the first cyclist. He needs 7.5 days to complete one circle. The first cyclist needs 7.5 days to go one round. So in 30 days, he would have made 4 rounds. 7.5, 7.5, 7.5, 7.5. 4 times. Because 7.5 into 4 is 30. Then the second cyclist, he covers it in 6 days. So in 30 days, he would have done 5 rounds. He would have done 5 rounds. And the third cyclist, he would have done 6 rounds. So at the end of 30 days, they meet again at the starting point. The 3 persons will meet at the starting point at the end of 30 days. All right. Done writing, online students? Done, children, here? Finish writing? Yes. Online students? Done writing?
Completed, ma'am.
All right. So we'll have a look at the question again. A circular field has a circumference of 360 kilometers. 3 cyclists start together and can cycle 48 kilometers in one day, 60 kilometers in one day, 72 kilometers in one day around the field. When will they meet again? At the starting point, obviously. When will they meet again? From at the point where they started. The total distance is 360. Divide by 48, divide by 60, and divide by 72 to find the number of days each cyclist would need to cover 360 kilometers. So you get 3 new numbers now. We have to find the LCM because they'll be meeting at a later time. They cannot, because one round only one person needs 7.5 days to make one round. Okay, so they'll be meeting after a later time. So which means you're expecting a number greater than 7.5, which is the LCM of the 3 numbers. Which is the LCM. But since we have a fraction, we are worried as to how to find the LCM of 15 by 2, 6, and 5. So we'll get rid of the denominator 2 by now multiplying every number by 2. So we get new numbers 15, 12, and 10. Find the LCM of these 3 numbers. What is it? 16. But that's not the required number because we had multiplied by 2. So do the opposite, divide by 2. If you had added 2, you will subtract 2, the counter effect, the opposite effect. So now divide by 2, 60 by 2 is 30. So the 3 friends will meet again after 30 days. If anyone hasn't completed, joined late or some reason, take a screenshot. This is the first slide, take a screenshot. Online students. There's the next one. All right. The next question. Yeah, please find the LCM of these 2 numbers. Sorry, HCF of these 2 numbers. Find the HCF using FTA, the fundamental theorem of arithmetic. Who can state the fundamental theorem of arithmetic? We saw this once earlier. Subbalakshmi. What is the state fundamental theorem of arithmetic? Forgotten. Yeah, how do you state the theorem? Yeah, tell me.
Every composite number can be expressed as a product of its prime, and this factorization is unique apart from the order in which the prime factors occur.
Very nice. Very good, Subbalakshmi. Very good. Thank you. Yeah. So every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. Write out that once and then start working, meaning then find the HCF of these 2 numbers. Write out FTA once in your What's the HCF? 24. Tell me the factors. 408 is equal to 2 power 3, 2 cubed into 3 cubed. 3 into this is 3 into 43. Okay, so we need to write the common factors once. Only the common factors, not all the factors, only the common factors. So 2 and 3 with their least powers, which is so the HCF of 408 and 1032 is expressible in this form. The HCF can be expressed like this. So that means it's given that 1032M minus 408 into 5 is equal to the HCF of 408 and 1032. This is what is given to us. This is what is given to us. This one, the HCF of these two numbers, see the HCF of these two numbers can be written in this form. The HCF of these two numbers can be written in this form. So now we found the HCF of the two numbers, which is 24. So like this, we have an equation is equal to 24, correct? Yeah, so now solve this and find the value of M. Done, children? Finish writing all of you here? This is not a likely question for you because you do not have Euclid's division lemma. But we have to do this using EDL. But this, if at all they go beyond the syllabus, this one question can be asked. So we'll just do this to be safe. It's a very simple thing. Okay, let's start. So express the HCF of these two numbers as a linear combination. All right. So let's find the HCF of these two numbers using the division process. It goes like this. Write the greater number. Take the greater one as the dividend. The smaller one as the divisor. You have two numbers with you. The greater of the two numbers is the dividend and the other one is the divisor. Now 575 how many times? 2 times? 2 times how much? 1115. Quick. The remainder? Correct? Okay, now see here. Now next, see here. The remainder becomes the new divisor. See that the remainder becomes the new divisor. This is the remainder. 138 is the remainder. The remainder becomes the new divisor. And what is the dividend? The earlier divisor becomes the dividend. See here, like this. The earlier divisor becomes the new dividend. The remainder is the divisor. And the earlier divisor is the new dividend. Now again divide. How many times? Huh? Now tell me. 5? Yeah, do. 138 how many times? How much? Tell me everything. 4 times, huh? 4 8s are 32, 3 carried over, 12, 15. Okay. And the remainder? 23. Now this becomes the remainder becomes the new divisor. And the earlier divisor becomes the new dividend. So now 6 times. So you should continue this division process till you get 0 as the remainder. You must continue this division process till you get 0 as the remainder. Now we got, in 3 steps, we got 0 as the remainder. Now, okay, finish writing. All of you finish writing? All right. So, we have 3 stages in division here, and the remainders in the 3 stages are 138, 23, and 0. The first remainder we got was 138, and then we got 23 as a remainder, and then the third last step we got 0. The remainders, the different remainders are 138, 23, and 0. Which is the last non-zero remainder? 23. That is the HCF of the two numbers. This is how we find the HCF using Euclid's division lemma. The last, okay, the remainders are 138, 23, and 0. 0 is the last zero remainder. The last non-zero remainder, the last remainder but not 0 is what? The last non-zero remainder is 23. The last from behind, the last non-zero remainder is 23. And that is the HCF of the two numbers. But what is the question here? You should express the HCF as a linear combination of the two numbers given. We'll see how to do that. So now, are we done with the division, online students? Shreyas?
Yes, ma'am.
All right. So now, shall I start? Okay. Now, which is the HCF 23. So we start from there. The HCF 23. The HCF 23 is equal to, we just use the division algorithm, nothing else. The division algorithm. Okay, let me show you something else. 1 minute. Look at this simple division. Okay, so what is the remainder 3? The remainder 3 is the dividend minus 4 into 3. Yes or no? The remainder 3 is the dividend 15 minus 4 into 3. If this is difficult, then we'll write the algorithm. What is the algorithm? See here. Dividend is equal to divised into quotient plus the remainder. So what is the remainder? Remainder is equal to dividend minus divised into quotient. That's what I wrote now. This is the division algorithm. Dividend is equal to divised into quotient plus remainder. So what is the remainder then? Dividend minus transpose this. Dividend minus divised into quotient. That's what we're using here. That is what we're using here. So the remainder 23. See, from where should we start? We should start with the HCF. From where should we start? We should start with the HCF. And which is the HCF? The last non-zero remainder, which is 23. 23 is the HCF of these two numbers. We start with 23. The remainder 23 is equal to the dividend 575 minus the divisor 138 into the quotient 4. Difficult? Yeah, yes, yes. No, we'll not go ahead. No, 1 minute. You tell me what. Okay, from where should we start? We should start with the HCF. Which is the HCF? The last non-zero remainder, which is 23. We should start from there. This is the remainder. Look at that step alone. 138, 4s are. We have 575 here and 552, 23 is the remainder. Look at this stage. Look at this stage alone. Okay, look at this stage alone. So 23 is equal to 575 minus 138 into 4. Correct? Yeah. Now 23 is equal to 575 minus, which is the remainder here again? Which is the remainder again? We listed all the remainders. Which are the remainders? 138, 23 and 0. 138, 23 and 0 are the remainders. Now, among these three numbers, 575, 138 and 4, which is the remainder? 138 is the remainder. Use the same rule there. Okay, so minus, for 138, you're going to write something into 4. Put that 4 outside. See, you're going to keep replacing the remainder with the division algorithm. Now, what is 138? Then look at that stage. 1288, 575. 2 times is 1150 and the remainder is 138. So the remainder is 138. Replace the remainder. See, here we have three numbers, of which this is the remainder. We're going to replace only the remainder. So the remainder 138 is equal to the dividend 1288 minus the divisor 575 into the quotient 2. Correct? That's all. We are done with the remainder. So that's all. Now we just have to simplify this. This procedure will continue till you have some remainders. Once you have replaced all the remainders with the expressions using the division algorithm, you are done. There is no further remainder. We had only 2 remainders, 23, which is the HCF, and one more 138. 0 we don't take. There are 3 remainders. We start with 23 and we go ahead. We go up and we meet 138. That's all. So now just simplify this. How to simplify? 23 is equal to 575 minus, you need to multiply, no? 1288 into the 4, which is outside, minus into minus plus 575 into 8. Now the thing is, this 4 should be multiplied with 575 or 2. That's the question now. Should you multiply this 4 outside with 575 or 2? Multiply 4 with the quotient, not the divisor. Don't disturb the divisor. 575, 2. 575 is the 575 and 2. What is 575? The dividend. What is 575? I'm sorry, the divisor. 575 is the divisor. See here, 575 is the divisor and 2 is the quotient. Multiply this 4 with the quotient, not the divisor. So 575 into 8. I'll do it again if it's difficult. No, don't have to get nervous. That's also 23 is equal to, we are done. 23 is equal to 5. Now we have 575 into 1. Let me write it like that. 575 into 1 minus 1288 into 4 plus 575 into 5. So like 575 ones are and 575 ones, 575 8 times. So 575 9 times we have. Okay, so 23 is equal to 575 9 times plus 1288 into minus 4. So we have expressed the HCF 23 as a linear combination of two numbers. See, 575x plus 1288y, where x is equal to 9 and y is equal to minus 4. If at all you get, you might get this question. Nothing beyond this you'll get from EDA. Now please take down. Yeah. Done, children? Deepika? Rajeshwari? Finish writing? Rajeshwari?
Yes, ma'am.
Yeah, Lakshmi, Priyasha, Shreyas, Sashmi? Raise your
Yes,
hand
yes.
if done. Okay, okay, fine. All right. So this is how we express the two numbers. We express the HCF as a linear combination of the two numbers given. The two numbers given are 1288 and 575. We need to express the HCF. We need to express the HCF of these two numbers as a linear combination using these two numbers. Listen to the question carefully. We need to express the HCF of these two numbers as a linear combination of these two numbers, the same two numbers. So first we have to find the HCF. So using only if you find it using this division method, it will be easy for you to do this procedure. So this is how you find HCF using Euclid's division lemma. You know how to find it using the fundamental theorem of arithmetic, using the prime factors. That's what you do, right? So here we found using the division process. And then from where to, then you should, look at the remainders at the different stages. The remainders are 138, 23 and 0. Which remainder is the HCF? 23, the last non-zero remainder. So 23 is the HCF. So we start from there. 23 is the remainder. And using the division algorithm, you can write the remainder as dividend minus divisor into quotient. So take that division part separately. Take that division portion separately. And write the remainder as dividend minus divisor into quotient. And then in that line, so in this one, so see here, we started like this, and here this is the remainder. This is the remainder. Replace this remainder. Replace this remainder using this one. So it's 1288 minus divisor into quotient. This into 4, we have put it outside here. See, this is 1388. From here to here is 1388. Into 4. Now multiply. Open the bracket. So it will be minus 1288 into 4. And minus into minus plus. Multiply this one, this quotient with 4. So 2 4s are 8. 575 into 8. So here we have 575 into 1. And this is 575 into 8. It's like 575A and 570. It's like a 1A and 8A. 1 into 575, 1A. 8 into 575, 8A. 1 into 575, 1A. 8 into 575, 8A. What is 1A and 8A? 9A. So 9 into 575 or 575 into 9. So that's what is here. And then this one as it is. So normally we write it with a positive sign. So take a plus here and it will be minus 4. So you can see here 575 into x plus 1288. So these are the two given numbers. 575 and 1288 are the two given numbers. So linear combination of these two numbers. Where is it a linear combination? You can see x and y, no? So it's a linear equation. Can you see it's a linear equation? X and y, it's linear, right? Yeah. So this is the linear combination. So we have written the HCF 23 as a linear combination of x and y. As a linear combination of the two numbers given. Is it fine? Where x is 9 and y is minus 4. So in this question, there is a word in the question which gives you the clue if you have to find the LCM or HCF. Online students, attentive? Raise your hand. Online students, use the emoji, raise your hand. Shreyas, Rajeshwari, Lakshmi, Deepika. Others, where is Priyash and Sashmin? Sashmin, are you there? Okay. Okay, the question is find the largest number which divides. See, this is the word which is very important or which gives us the clue as to if you have to find the HCF or LCM. Please listen. Find the largest number which divides divides these two numbers, leaving remainder 6 in each case. So the number which you find should divide this and this. That means that it, okay, 1 minute, 1 minute. I'll see. See here. Children, if you are looking for a number like this, see, supposing two numbers are given to you. Let's consider two numbers. Let's consider two numbers like say 12 and 20. Okay. If you're finding, if it is this one, if you're finding an X like this, listen to me fully, you will understand. If you're looking for the numerator, that means this number should be divisible by 12 and 20. You understand that language? When you're finding the numerator, that means you're finding a number that is exactly divisible by 12 and 20. If you're finding the numerator, see when it is, okay, see whenever it is division, divisible, divides, it's about division. So the thing is, you will be finding two things. You will not find the remainder or the quotient. You will find the dividend or the divisor. If you're looking for the dividend, you're looking for the LCM. If you're looking for the divisor, you're looking for the HCF. If you're looking for the numerator, you're looking for the LCM. If you're looking for the denominator, you're looking for the HCF. Children, see, in such questions, it's about a division process. We are not trying to find the remainder or the quotient. Remainder and quotient you will get when you know the dividend and divisor. When you know two numbers called the dividend and divisor, by dividing you will get the quotient and remainder. So we are not finding the quotient or remainder here. We are finding either the dividend or the divisor. If you want the dividend, you want the LCM. If you want the divisor, you want the HCF. So where do you normally write that? Not normally. Where do we write the dividend? In the numerator. Now, please listen, online students. Are we there? Say yes, all of you.
Yes, ma'am.
Yes.
Okay. So if you're looking for the numerator is the dividend. You can make a note of this. So if you're looking for the numerator, you're looking for the LCM, which is the numerator is the dividend. If you want the denominator, that's the divisor. That means you want the HCF. If you want the dividend, you need the HCF. Sorry, LCM. Divisor, HCF. So the next thing is, are you drawing? What are you doing in your paper? Okay. Okay. Yeah. Okay. So here, find the largest number. Don't go by the words largest, smallest, and all that. Find the largest number is find a number which divides these two numbers. Divides means you're looking for the denominator or numerator. Okay, tell me one by one. See, read this question. You are looking for a number that divides 615 and 963. Are you looking for the denominator or numerator? Denominator. Think. Huh? You want some more time to think? Yeah, think. Online students? Divides. Denominator. You'll have to find a number that divides the given numbers. That should divide the two given numbers. So you're looking for the denominator. That means you want the HCF. That means you want the HCF. But it should leave a remainder of 6 in each case. Whenever you're finding the HCF, subtract the remainders and then find the HCF. If it is the LCM, we'll always find the LCM and then we'll do some add subtract. Remember that also. See, whenever some number is given, this is the remainder or the remainders are given to you. If you're finding the HCF, do the subtraction or addition and then find the HCF. If you're finding the LCM, first find the LCM and then do the addition or subtraction. So make a note of that also. How do I write that? If you're finding the HCF, add or subtract and then find HCF. If you're finding the LCM, find LCM and then add or subtract. You will understand. Just make a note of all this, children. For LCM, you should always find and then do the manipulation. For HCF, you should manipulate the numbers and then find the HCF. Make a note of all that you see on your screen, children. Noted? Okay, so now which divides, meaning you're looking for the denominator, which is the HCF. Now find the HCF. Use prime factorization. If you're feeling sleepy, go wash your face and come. Yeah, go. Wash, you can just stroll outside and come back. You can go out and see the restroom there. Yeah. Splash water on your face, on your eyes. All right, now let's answer this question. Can you please turn off the light and close the door? I'm sorry. Yes, I'm not finding the HCF, children. Please tell me the HCF. Now, yeah, should you subtract and then find the HCF, or should you find the HCF and then subtract? Subtract and then find the HCF. So we need to find the HCF of, see here, to find HCF of, 1 minute, I'll just write it like this, to find HCF of 615 minus 6 and 963 minus 6. Is my presentation correct? This is what we need to find. HCF of 609 and 957. Yeah, this is what we have to find. See, I wanted to write this so that when you look at the first step, you realize, you recall what you have to do. So this step is important. You need to write this. You need to write this. When you're revising this, when you look at the first step, you recall the procedure. The first step is very important. Please make a note of that. '87. Yes, 87. So you work the HCF and so here Kanishka says it is 87. So the required number is 87. So 87 is the largest number that divides these two numbers, leaving remainder 6 in each case. 87 is the largest number. Is the largest number that divides 615 and 963, leaving remainder 6 in each case. All right, so I told you, so divides means you're looking for a number that divides the two given numbers. So denominator you want, HCF, and remainders are given. To find HCF, you should first manipulate the numbers. You must first subtract. Remainder means you should subtract and then find the HCF. Okay. Next question. So again, that divides the number that divides these two numbers. So we should find the HCF of 2011 minus 9 and 2623 minus 5. Find the HCF and that's a required number. Find the HCF all of you. Yes, anybody online can tell me the HCF of these two numbers?
Is it 77?
77. No. 22. You also got 22? Have I not written the numbers correctly? 1 second. 20. No, I have a different answer with me. Is anyone getting 154?
Ma'am, I got 154.
Yeah, even I got 154. Yeah, Subbalakshmi, just share your answer on WhatsApp. Can you do that?
Yes, ma'am.
Yeah. $154, yeah.
I too got 154, ma'am.
Yeah, Shreyas, you checked where you went wrong?
Yes, ma'am.
Okay. So I'm taking Subbalakshmi's steps. All right. So she says 2002 is 2 into 7 into 11. And 2618 is 2 into 7 into 11 into 17. So the HCF is 2 into 7 into 11, which is 154. See, children, we have to find the prime factors of the two numbers given. We should not do this, primary school method. We should not do this method. If it is MCQ like this, you will not be able to express both as the product of its primes. You must find separately. You must write this number as a product of its factors. This one also separately you must write. You will not get marks. If you do this, you will not get marks. If it's MCQ, you'll have to select the correct option, then fine. Otherwise, you have to show this presentation. Oh yeah, she's written 13, meaning there is 13 in her book. Thank you. There is 13 in her book. 2, 7, 11, 13 is there. 2, 7, 11, 17. All right. So 154 is the greatest number. You'll have to write it like that. 154 is the greatest number that divides 2011 and 2623, leaving remainders 9 and 5 respectively. So like this, they might give you 3 numbers and 3 remainders. Now here we have 2 numbers and 2 remainders. You may have 3 numbers, 3 remainders, same question. So do the same procedure. So here the number which you're finding, that should be divisible by the number which you're finding. You should find a number that is divisible by 520 and 468. So numerator you have to find, which is the LCM. Divisible. The number which you're finding should be divisible by this and this. So you're looking for the numerator. Okay. So if you have to find the LCM, you must first find the LCM and then do the addition, subtraction, whatever. So first find the LCM. Oh, minus 17, because it should be increased by. First find the LCM. What do you have in your lab? Huh? Give me the pen, please. I told you don't find like this. You should find separately for 520 and for 468. Have you taken 418? You must do it separately. How will you present? You must write, see, in our syllabus, you have to use FTA. That means you must write each number as a product of its prime factors. This way you will get the LCM straight away. This is, like junior school or middle school. You're in high school. Yes, children, 520 is equal to what? Four 68. 2 square into 3 square into 13. Correct? So how do you find the LCM? You should write all the prime factors, not only the common ones, everything. So there is 2, there is 3, there is 5, there is 13, and raise them to the highest power. Okay, highest power. So highest power 3, 2, and what's the number? 4080. So what's the required number? 4680 minus 17. I have the final answer, 4663. So if you increase 460, actually what is the LCM? 4680. And this LCM will be exactly divisible by 520 and 468. The LCM will be exactly divisible by 520 and 468. So if you reduce it by 17, it will not be divisible, right? If you reduce it by 17, you form the LCM. So the LCM is exactly divisible by 520 and 468. Now what did you do? You manipulated that LCM. What did you do? You reduce it by 17. So now it is not divisible. Now it's not divisible. So now when you add 17 to this number 4663, you will get the LCM. So that is divisible by 520 and 468. See, the question is find the smallest number which when increased by 17. The number when increased by 17, it should be divisible. So after finding the LCM, you decrease it by 17. So then when you increase it by 17, it will be divisible. Should not add 17. Should reduce it by 17. Yeah, so 4663 is the required number. This number, when you increase by 17, it will become 4680. And that is divisible by 520 and 468. Yes, children. We have to start similar triangles. I have 2 more to go. Done, children? So divided. That means LCM you have to find. So first find the LCM. $224. Yeah. Now see here, children. In the rough column, what is 28 minus 8? No, because the remainders are 8 and 12 when divided by 28 and 32. Now the remainders are different here. When you're finding the HCF, you know, we first manipulate the given numbers. So if there are 3 numbers and 3 remainders, you can subtract with each number the respective remainder. But here what we do in LCM, we find the answer. The answer is only one answer. But there are 2 things, remainders 8 and 12. When we find the HCF, there will be 3 numbers and 3 remainders. So to each number you will subtract or add whatever. You will have 3 numbers and 3 remainders. So you will subtract the remainders from the 3 numbers. That's different. But LCM, what you have to do, you should first find the LCM. So now answer is only one number you have. But you have 2 remainders like 8 and 12. So how do you do this? So what you do, take up these numbers 28 and 32. Subtract the remainders. You get 20 here. And when you subtract 12, you get 20 here. Now this number should be subtracted. So the required number, you can check if you want. Required number is equal to 224 minus 20. How do you get 20? Like this. From this working, we get 20, which is 204. So when you divide 204 by 28, when you divide 204 by 28, when you divide 204 by 32, the remainder will be 8 and 12 respectively. You can check. Next question. So what I was telling you is here LCM you have only one answer, but remainders you have 2. So how do you handle it? Do this and you get one single number 20 now. There's only one number now 20. That number you subtract from the LCM. You can check if you want. I've written it down for you. When you divide this number 204 by 28, the remainder will be 8. And when you divide 204 by 32, the remainder will be 12. So the required number is 204. Sorry. Oh, I'm sleeping. Still sleeping, after lunch, this class, yeah. What's the smallest number when divided by 35, 56, 9 leaves remainders of 7 in each case? Divided. So again, LCM it is. That number when divided by these numbers. What is the smallest number when that is divided by 35? That number when divided by 56. That number when divided by 91. So by 91 means 91 comes in the denominator. So that number is in the numerator. So you'll have to find the LCM. So first tell me the LCM of 35, 56 and 91. Huh? So sorry, finish and tell me the answer. Huh? சேர்த்து பண்ணக்கூடாதுன்னு சொல்றேன். அதுக்கு மார்க் கிடைக்காது உங்களுக்கு. தனித்தனியா தான் பண்ணணும். You should use a fundamental theorem of arithmetic. 5 sevens are 56. 2 cube 8 sevens are 91. 7 13s are 91. So LCM is equal to 2 into 1. How much? And the number in the now where is the number? What's the answer? Yeah, correct. Sorry, I saw the next answer. Yeah, correct. 2 cubed into 5 into 7 into 13, correct? Ram? What's answer? Correct. Got this? Yeah. Now tell me, children, when you divide 3,640, see, when you divide 3,640 by 35, what will be the remainder? When you divide 3,640 by 35, what will be the remainder? Say confidently. Huh? Come on. What is 3640 for 835? It's LCM, meaning for these three numbers, it's the LCM, right? What have we found? We have found the LCM of 35, 56 and 91. What is the LCM? 3640. When you why online students, you're sleeping, all of you? Tell me what will be the remainder? Because simple questions are always very difficult to answer. What is the remainder? What is the remainder? Online students, wake up. Lower your hands, all of you. Class, lower your hands. So Deepika is awake. Okay, all of you are awake. Sashmin, wake up. Yeah, see. Yes, children. See, online students, my question is, what is the remainder? Tell me the remainder. Somebody's come. Yeah, online student. No, 1 minute. One. Children, what's the remainder? 0? Trace.
0 in all cases.
Yes, ma'am.
Very good. Who was that? 0 in all cases. Very good.
Creation.
Priyasha, yeah. That bold voice is what I want. But what is the requirement? It should leave remainder 7. So increase the LCM by 7. If it is 347, the remainder will be 7. If it is 347, the remainder will be 7. If it is 347, if it is 7 more, then when you divide, the remainder will be 7. If it is the LCM, the remainder is 0. If you increase the LCM by 7 and then divide, 7 extra is there, right? So that will be the remainder. So here the required number is 3640 plus 7, which is 3647. Because LCM meaning remainder will be 0. Increase the LCM by 7. Then when you divide, 7 will be the remainder in every case. So that's the question. What is the smallest number that when divided by these 3 numbers? So 3647 is the smallest number. And that number, when you divide by 35, 56, and 91, the remainder will be 7 in all the cases. Okay, the other 3 sums, I'll give it as homework, fine, because I'll have to start similar triangles. I have 3 more questions on real numbers, not 3, 5 actually I have. Maybe next class or homework, I'll see. Now, let's just talk about this. Now, supposing I'll just read this question. The traffic lights, online students, listen carefully. The traffic lights at 3 different road crossings change after every 48 seconds, 72 seconds, and 108 seconds. The traffic lights, unfortunately in Trichy, we don't get to see traffic lights at the road junctions. 4 roads meet at a point. 4 roads will meet and the vehicles will meet, but there is no traffic signal there. Correct? Yeah. But right. So there are so many in Trichy, we find so many places where roads meet, 3 roads meet, 4 roads meet, but we don't find the traffic signal there. But we find a traffic constable trying to manage the traffic, but he's also caught in the traffic. Okay, so 3 traffic lights, the signals, red, orange, green, the traffic lights at 3 different road crossings. Meaning where at the junctions, at 3 different junctions, the road, the traffic lights, they change. The colors change, right? From red to orange and then to green. The color changes from red to orange and orange to green. Correct? Yeah. We haven't seen much of it, so we are like, okay, so they change after 48 seconds. So in one signal, the color changes after 48 seconds. The color from red to orange, orange to green, every 48 seconds, the color keeps changing. And after green, it goes back to red. So that keeps happening at intervals of 48 seconds. In the second traffic signal, in the second one, the lights change after 72 seconds. So it's now red. After 72 seconds, it becomes orange. And after 72 seconds, it becomes green. Again, after 72 seconds, red. So it keeps happening like this. And at another signal, it changes every 108 seconds, after every 108 seconds. So when the traffic is really heavy, there the lights will change, like delayed. There'll be a delay, like 108 seconds, meaning there's a lot of traffic there. So much traffic has to pass by. Then only it will change. If the lights are switching or changing quicker, that means the traffic will be less there. Otherwise, okay, let's not go there. Now that's what is the situation. If they all change simultaneously at 8 a.m. So imagine that, the signals, the traffic signals, they've been switched off in the night. Traffic summa current waste. Solar energy just imagine electricity. So the traffic lights, they're turned off during the night, and 8 mani kaatala they're turned on. So 8 maniki they're all at red. Moon light or red layer kippo. If they all change simultaneously at 8 a.m. So we'll just assume they're all at red or whatever color. They're all at one particular color now. If they all change simultaneously at 8 a.m., then at what time will they again change simultaneously? 8 o'clock in the morning, they all change. Illame ore time la mari kipo. Illame. Okay. So if first signal adutha color eppo varum after 48 seconds. Next signal adutha color eppo varum after 72 seconds. Adutha signal, where signal is it? That the color will change after 108 seconds. So if first signal la marla, second la maradu, third la marla. But same all the three simultaneously, when will they change again? Is the question. That's the question. At what time? 8 manikki moonu maarirukku. If at what time will the three traffic lights change their colors simultaneously? So are you looking for a bigger number? Are you looking for a number greater than 48, 72 and 108? Okay, so you find whatever you want to find and tell me at what time. Start. Do you want the question, children? Okay. I'll just write the numbers. You start finding the LCM or HCF. I'll just write the numbers for you. These are the numbers, children. Okay, I'm writing the question. You find the LCM or HCF, whatever for the three numbers. Writing the question for you. One second. This is the question. Huh? LCM is 2000. It's LCM. I'm having a completely different answer. What have you found, LCM or HCF? What is the LCM? Yes, that's what I have. 432. Yes, Priyanka and Kanishka. பயமா இருக்காதீங்க என்ன ஆளுக்கு ஒரு ஆன்சர் சொன்னா எனக்கு பயமா இருக்கு. Online students, what is the LCM of these three numbers?
432.
Correct. 432. 432. Check Nandini. எங்க தப்பு பண்ணிருக்கோம் பாரு. Sashmin, Shreyas, Priyasha, Deepika, Rajeshwari. 432. Have you got? You should have found the LCM of the three numbers, which is 432. Found the LCM? அதாவது அந்த மூணாவது லைட் வந்து நெக்ஸ்ட் மாறுறதுக்கு குறைஞ்சபட்சம் 108 செகண்ட் வேணும். அப்ப அதுக்கு முன்னாடி எப்படி அது மாறவே மாறாது. அந்த மூணாவது லைட் இருக்குல்ல, அந்த மூணாவது லைட் வந்து கலர் மாறுறதுக்கு மினிமம் அதுக்கு 108 செகண்ட்ஸ் வேணும். அப்பதான் அது அடுத்த கலருக்கே மாறும். அப்ப நீ HCF கண்டுபிடிச்சா இன்னொரு ஸ்மாலர் நம்பர் கண்டுபிடிக்கிற. அப்ப அது மாறவே மாறாது. The question is இந்த மூணு டிராபிக் சிக்னல்ஸ்லயும் கலர் எப்போ மறுபடியும் மாறும். அந்த மூணாவது லைட்டுக்கு நெக்ஸ்ட் கலர் மாறுறதுக்கு 108 செகண்ட்ஸ் வேணும். அப்ப நீ அதோட HCF கண்டுபிடிச்சா இன்னொரு ஸ்மாலர் நம்பரா இருக்கும். அது எப்படி மாறும்? மூணாவது லைட் மாறவே மாறாது. It's not the HCF, it's the LCM. So children, we are supposed to find the LCM of the three given numbers 48, 72, 108. Rajeshwari, have you got the LCM?
Yes, ma'am.
What is it? Share your picture on WhatsApp, Rajeshwari. I want all of you to share your picture on WhatsApp. Sashmin, Shreyas, Priyasha, Lakshmi, Rajeshwari, and Deepika. All of you, I need to check if you're all writing and active in the class. Take a picture of this answer and put it on WhatsApp for me right away. Don't work now. Send what you have in the book at the moment. Yes, I got it from Lakshmi first. Very good, Lakshmi. I'm so happy. Very nice. Thank you, Lakshmi. Next. See, where are the others? You're working in a hurry now. Send the pictures, all of you. Don't waste time. So now 432 children. What is the answer? You found the LCM for 48 seconds, 72 seconds, and 108 seconds. So the answer is 432 seconds. Okay, so how many minutes and seconds it is? 420 minutes is how many? 420 seconds is 7 minutes, right? So 432 seconds is equal to 420 seconds plus 12 seconds. Oh, so that is 6 sevens are 42. So 7 minutes and 12 seconds. So the lights will change simultaneously. I'll just write SIM for simultaneously, okay? Will change simultaneously. SIM is simultaneously at 8 hours, 7 minutes, and 12 seconds. When the time shows 8 மணி ஆயிடுத்து 8, 7 and 12 seconds. 8 hours காத்தால 8 o'clock 8, 7 ஆனப்புறம் இன்னும் 12 seconds ஆனோம். அப்ப எல்லாம் திருப்பி சேர்ந்த மாதிரி மாறும் என்ன? All the 3 lights will change simultaneously. அதுக்கு முன்னாடி ஒன்னு மாறி இருக்கும், ஒன்னு மாறி இருக்கும், ரெண்டு மாறி இருக்காது, இல்ல ரெண்டு மாறி இருக்கும், ஒன்னு மாறி இருக்காது. அது மாதிரி மாத்தி மாறும். பட் மூணு simultaneously at 8 hours, 7 minutes and 12 seconds they'll change. Yeah, finished this. See, I have not received photo from anyone else. Huh? What does this mean? This means we don't have a phone near us. Yeah. What does it mean? No, the others have to tell me the reason. Why, Shreys? Why have I not received the picture from you? Priyasha, Rajeshwari and Deepika, we are wasting time like this.
Ma'am, I don't have the phone to send pictures, ma'am. I have my laptop here.
Then you should unmute and tell me, Rajeshwari. I've been asking you, right? I've been asking the class.
Ma'am, I rejoined now, ma'am. My laptop gone hang, ma'am. I couldn't turn on my mic.
Okay. Deepika will not be able to unmute and talk. Fine. Rajeshwari has given a reason. What about Priyasha and Shreyas? Okay. Fine. We are now going to switch to similar triangles. So here we find the LCM because we are looking for a number greater than 108. So we find the LCM, and LCM is in seconds. Seconds, because we found the LCM for 48 seconds, 72 seconds, and 108 seconds. So it's in seconds. So we'll meaning break it to minutes and seconds and add it to 8 o'clock. Because the question is at what time? At what time? Okay, so now it's time for similar triangles. Similar triangles, one particular question in the test, Subbalakshmi and Rajeshwari had asked me. I couldn't answer, children, so now I'll do that. Rajeshwari and Subbalakshmi, after the test, you wanted the answer to one particular question. I'm so sorry, I couldn't answer you immediately. Now I'll take that as the first question. Yeah. Let's write down the question first. PQRS is a, give the heading similar triangles. PQRS is a trapezium. PQRS is a trapezium with PQ parallel to SR. Diagonals PR and SQ intersect at M, and triangle PMS is similar to triangle QMR. Prove that PS is equal to QR. PQ parallel to SR. I'll work it and then explain. So please work right along with me. PM by QM is equal to MS by MR is equal to PS by Q. All right. So now this we know. This part there's nothing to explain. One pair of triangles that are similar is given. So in similar triangles, corresponding sides are proportional. And then we already know that you can prove these two triangles, MSR and MQP, to be similar. Vertically opposite angles and alternate angles. Okay, now we have to do something with the proportions. I'll tell you what you have to do. Finish writing, children? Now compare the proportions. Compare the proportions. See here, PM, see here. I'm just reading it. All of you listen carefully. I'm reading the first one, PM by QM. Can you see PM here? PM is here. QM is here. Okay, so here PM and QM. Children, PM by QM here. Where do you find PM here? Here. Where do you find QM here? Okay. Okay, now MS by MR. MS is here. MR is here. Sorry, Pranav. Are you able to concentrate? You want to wash your face again? MS by MR. All right. Then PS by QR. Do you have PS and QR here? No. No. See, children, I'm just reading. PM, PM. QM, QM. MS, MS. MR, MR. So, 1 minute. So, children, now we are going ahead only with, it's what? MR by MP. Yeah. So, we are ignoring this. You write it first. Now just slash this across this and cross this. You understand why? You understand why? We don't want these two ratios. We don't want these two ratios. Because, okay, because I answered already. We don't want these two ratios. So now what we'll do, we'll come back to this. We'll come back to this. And now write PM by QM is QM is equal to MS by MR. This one is 1. And here MS by MQ is equal to MR by MP. This is 2. This is 2. Now we have to compare these two. Is there any ratio which is common to compare? Is there any ratio common to compare? PM by QM. Okay, see here, this is MS by MR. Can you see here? But this is MS by MQ. This is MS by MR. See now, children, now we have two proportions. We have to have some ratio common in these two proportions. Only then you can compare these two. There should be some ratio common in these two proportions. Only then we can proceed. So we're now trying to figure out that. Okay, so there is MS by MQ here, but here it is MS by MR. All right, now see, there is a property of, there are some properties of proportions. One of it is called alternando. One of it is called alternando. Okay. So there are many, we don't have that in our syllabus. So there are, proportions called componendo, dividendo, alternando, invertendo. So they are properties of proportion. But for our syllabus, it's enough if you know alternando. Now, how do you use this alternando? If you have a proportion like A by B is equal to C by D, you can alter this. You can write it as A by C is equal to B by D. That's alternando. That is alternando. Meaning you can bring the C down and take the B here. So what we're going to do is, see here in this one, MS by, we're going to use alternando property here. We're going to use alternando property here. MS by MR is equal to MQ by MP. Using alternando. Using alternando. So that's why we are going to call this one as 2. So you keep marking with your pencil. Then keep rubbing. When you want to change, you keep erasing it and change it. So now you say, what is this? You mark that as 1 and 2. Now I'm doing that for your sake because we normally mark it as 1 and 2. No, you do that with a pencil. And finally, when you settle down with something as 1 and 2, then you use your pen and mark 1 and 2. So this is our 1 and 2. Now you have the ratio MS by MR common to both. So from 1 and 2, what? From 1 and 2, what? Huh? From 1 and 2, what is a new proportion? Priyanka, no, this girl, Nandini. Repeat. Which is the ratio common to both? Louder. MS by MR. So when you compare 1 and 2, what is the new proportion? Correct. Anybody online can tell me when you compare 1 and 2, what is the new proportion? I have not had my lunch and I'm screaming like this.
PM by QM is equal to MQ by MP.
Thank you, Priyasha. Very good. So PM by QM is equal to MQ by MP. That's the new proportion. Understood, Tarun? Tell me what is the new proportion? That is a new proportion. So the new proportion is PM by QM from 1 and 2. 1 and 2. From 1 and 2, PM by QM. PM by QM is equal to PM by QM is equal to MQ by MP. MQ by MP. Cross multiply. PM, MP, both are the same. So PM square. PM square is equal to, now what is that we'll have to prove? I forgot that. PS is equal to RQ. That means you should prove it's an isosceles trapezium. You will have to prove that PS is equal to QR. You will have to prove that the non-parallel sides are equal. Non-parallel sides are equal, meaning you'll have to say that it's an isosceles trapezium. So what do you get? PM square is equal to QM square, correct? So PM is equal to QM. PM is equal to QM. Now what do you have to prove? PS is equal to QR. Ernie? Yeah, children. We need to prove that PS is equal to QR. So where is this ratio PSQR, PSQR? Here, PSQR is here. PSQR is not here, no? See here, there's PSQR here. See, we've got this one. PM is equal to QM. We need to prove that PS is equal to QR. So we are searching for PS and QR in the proportion. Here it is. Here it is. And what do we have here? PM and QM. PM. So we have this here. We have this one. PM is equal to QM. And we have to prove PS is equal to QR. So we'll take up these two. So from one, what do you have? PM by QM. PM by QM is equal to PS by QR. But PM is equal to QM, right? PM and QM, they're equal. So that means you can write PM by PM is equal to PS by QR. So 1 is equal to PS by QR. So PS is equal to Q. So PS is equal to Q. So see, you understand like this. It's very easy to write this one, it's given. Similar triangle, this is given. And this, you know, you can prove that these two triangles, that is, these two, look at the figure, these two triangles are given to be similar. And you can prove that these two are similar. So now from the given similar triangles proportion 1. From the other pair of similar triangles, you write another proportion 2. Now you have 6 ratios in the first one and 6 ratios. Sorry. We have 3 ratios in the first one and 3 ratios in the second one. Now we have to eliminate 1 ratio in the first and 1 ratio in the second. So we eliminated. How did we eliminate? That common line segments we checked. That common line segments PM, QM, we checked that. And we eliminated. I've crossed out 2, no? Yes or no? And then we compared the remaining, whatever is remaining. So we have PM by QM is equal to MS by MR in the first one. We call it 1. And then in the second one, after eliminating this, we have MS by MQ is equal to MR by MP. Now we have to compare these two proportions, but there was no ratio equal in both. So we used alternando. So we exchanged this. We brought, MR down and we took MQ here. Correct. And that makes it MS by MR. And we have MS by MR here also. So on comparing, you get PM by QM is equal to MQ by PM. And this, when you cross multiply, you get PM is equal to QM. PM is equal to QM. And there is PM is equal to PM QM here. And we have to prove that this PS is equal to QR. So take up this. We already know. Here we already know PM by QM is equal to PS by QR. We already know PM by QM is equal to PS by QR. So write that. Now we know that PM is equal to QM. So this QM, instead of QM, write PM because they're equal. So they get cancelled. Or you have another way of presenting. So you can also present it like this. See here. 1 minute. You can also present it like this. Okay, so you can say PM by QM is equal to 1. If PM is equal to QM, that means PM by QM is 1. Now, from 1 we have, what do we have? PM by QM. PM by QM is equal to PS by QR. PS by QR. Now this is 1 is equal to PS by QR. So cross multiply, PS is equal to QR. All right, take down children. Okay. Been sitting for a long time. If you need to use a restroom, please. You don't have to take permission for that. You just go. Yeah. All right, children. So now tell me, everything is marked in the figure. The question is a big paragraph, but I have marked everything in the figure. So you can see the parallel lines. We have two sets of parallel lines. Okay, that's all. Whatever you see, you have two sets of parallel lines. Now, you can do this using the concept of basic proportionality theorem, BPT, or using similar triangles. We'll do using both. We'll first use BPT. We'll answer this question using BPT first. You can also do it using similar triangles. Okay, we'll do similar triangles first. That's easier, meaning, yeah, that's kind of faster. Yeah, children. Now tell me the two triangles in which you have the first set of parallel lines with a single head arrows. In triangle, if I say QPD, which is the other triangle in triangle QPD, and that one set of parallel lines. And no, it should be like one triangle should be contained in the other. It should not be two different triangles. It should be like there's one triangle and inside that there's the other triangle. Huh?
Triangle BRD.
BRD, yes, BRD. Very good, Rajeshwari and Ram here in the class. BRD. So you should select the triangles like that. The triangles, it should have the parallel lines. And it should be like there's one big triangle and inside that there's the other triangle. So it's BRD. The big one is BRD. BRD is the big one. And inside that you have DPQ. And you have the set of parallel lines also, BR and PQ. Okay. So here, let me mark this. This is angle 1. Common angle. Angle 1 is common. And then angle 2 is equal to angle 3. Corresponding angles are equal. Correct? So I'll not write. Okay. So in these two triangles, angle 1 is equal to angle 1 common angle, and angle 2 is equal to angle 3. Corresponding angles are equal. So therefore, triangle what? Triangle DPQ. Similar to triangle DBR. Very good. DBR. Double A similarity criterion. So proportion dP by is equal to very good. Okay. So we're done with one set of triangles. Now the next one. The other one. Which is the other one? Now tell me. You got the idea. How to select the triangles, you understood now. BPR. Okay. No, 1 minute. BPR and ADC. ABC. ABC. I'm not able to see ABC. ABC. But this becomes like related to the earlier one. Only then see, one thing is you should have, we've taken some two triangles earlier, no? Related to that, when you take two other triangles, there will, when there are common line segments, more likely that you will have common ratios to compare. When you take, earlier we have taken two triangles, no? Related to that, if you take two other triangles, including the parallel lines, the line segments will be equal, so you will have equal ratios. Keep that in mind and select. Keep that in mind and select. Okay, this is one. I won't say this wrong. This is right. B PR and B ABC. DPR. 1 minute. DPR. Okay. DQC. DPR and BQC. Yes. This looks better. Yes. DPR. Yes. So you're coming from this side only. Yes. And DQC. Yes. This will help you. Because see, like earlier you took DPQ and DPR. Now we are taking PR and DCQ. So kind of they'll have they'll have some common line segments. That's all. See here, that parallel line extends here also like this. I think this is your doubt, Nandini. Inga irukku paru, inga and the parallel line idu varaikum irukku. So it's DCQ. This one DCQ. This is parallel. No, see here this one. So DCQ, this triangle, and DPR. So let's rename the triangles actually starting from D. We start from D here. So yes, children, first we took DPQ and DPR. Now we are taking DCQ and DPR. So we are expecting some line segments to be common so that we'll have ratios with the same line segments. Okay. Now, so again, how are they similar? DCQ angle 1 is there, no? Is equal to DPR also angle 1. And so in DCQ you have this one, and in DPR, this full thing. Okay, let me write angle DCQ is equal to angle DPR, correct? DPR. Alternate corresponding angles are equal. So triangle, therefore triangle DCQ is similar to triangle DPR, and proportion very good. So some kind of mission accomplished, sort of accomplished. Now compare. So there is DQ by DR, DQ by DR. That's why. Otherwise, if you take some other two triangles, no, you will not have common ratios to compare. So now DQ by DR, DQ by DR. Now the thing is what to take. You'll have to decide that. Now look at this. We have BD, CD and PD. BD, C, we have to find BD, CD, and there is PD here. BD, CD, see here, BD. And here there is CD here. Something, see, like some kind of a clue. You should be like an investigator now. I can't say a lot of why we are doing that, but I'm telling you, see, there is PD given here. Let's come again. So just think you're investigating something. Okay, so now. So we have to find BD into CD. Where is BD? BD. So there is BD only here. And there is CD only here. So that means we should take this ratio and this ratio. Because BD, CD, and there is CD here and there is BD here. So we have to take these two ratios. All right. And then there is PD given to you. PD is 12. See here, PD is here. PD is here. All right. So then what do you feel now? Since DQ by DR, you have DQ by DR in both, DP by DB is equal to DC by DP. The answer lies here. The answer is with this ratio and this ratio. Correct. The answer is here with these two ratios. Now we have to say that these two ratios are equal, and they are equal because there is dq by dr here, and there is dq by dr here also. So from comparing this, if you call this 1 and 2, when you compare 1 and 2, so from 1 and 2, since we have the same ratio dq by dr, so we understand that dp by db is equal to dc by dp. So now what is given? dp is given 12. Okay, so let's cross multiply now. Let's cross multiply. So you get dp square is equal to dc into dp. So dp is what is given? 12. So 12 square is equal to, we need BD and CD. So let me change that. Okay, CD into BD. Same thing. So that means BD into CD is equal to 144. All right, that's all. So it's simple. It's just similar triangles. Two sets we'll have to do. One pair of triangle similar, another pair of triangle similar, proportion. Okay. And how do you select the triangles? That is very important. You must, so like now what we did, selection of triangles is very important. And then from the proportions, you should identify with which you have to go ahead. For that, you should look at the information given in the question and what you have to find. What is given in the question? PD is given, and what you should find BD into CD. So using all this, you should select which ratio you'll have to go ahead with. That's all. It's very simple. Now we can also do this using BPT, but now if I do that, I think it'll become too much. Let's maybe do it in the next class. What do you feel about it? Marubadu in the sum and BPT, I don't think you can understand, meaning concentrate. We'll take up another sum. Yeah, take it down. But you can make a note of it. You can also do this using BPT. Done the slide, children? Done the slide, children? Priyanka? என்ன 2 வாட்டி எழுதுறீங்களா என்ன? Done? This is not very sensitive. Tell it bad or what? Yeah. You don't have this part of similar triangles, but you may get a question like this. So this is general like. So if AB is A minus 1 centimeters BC is 2 root A centimeter and AC is equal to A plus 1 centimeter. Okay, so this is given to you. Do the sides form a right triangle is the question. Do the sides form a right triangle? Form a right triangle. That's the question. This is, I think 8th standard children also can try this. No, I'm just telling you. Pythagoras theorem, converse of Pythagoras theorem is deleted this year. Okay. இது அங்கேருந்தா வரும் அந்த எக்ஸசைஸ்ல இருந்தா வரும் இது. ஆனா you can still expect a question like this because even otherwise you can answer this. Yeah, so what do we do with this? Yeah. So what do you do? AB is given. Find AB square. What is AB square? A minus 1 the whole square. So that's A square minus 2A plus 1. Find BC square. Okay, which is 2 root A the whole square, which is 4A units. Okay, you don't have to write anything otherwise. And then AC square. Find AC square. That is A plus 1 the whole square, which is A square plus 2A plus 1. Now what plus something should give you something. Is it possible? Check. Check. No, அப்படியே பார்த்து சொல்லுங்க. எல்லாம் போர்ட்ல இருக்கே. If you add anything, are you getting the third one? Which one? If you add AB square and BC square, you're getting AC square, is it? Okay. So AB square plus BC square. Not that we have to add AB square and BC square. You can add any two things, but and you should get the third one. Add any two and see if you're getting the third one. So here AB square plus BC square is equal to A square minus 2A plus 1 plus 4A. And that gives us A square plus 2A because plus 4A minus 2A is plus 2A plus 1. And that's nothing but AC square. That's nothing but AC square. So here we are getting AB square plus BC square is equal to AC square. So by the converse of Pythagoras theorem, ABC is a right triangle. And where is it right angled at? Which is the hypotenuse? AC is the hypotenuse. So it will be right angled at B, that other letter. If AC is the hypotenuse, B will be the right angle. Okay. So therefore by converse of Pythagoras, yeah, start writing. Converse of Pythagoras theorem, triangle ABC is a right triangle, right angled at B. Two more sums and we'll wind up the session for today. All right, done, children? By converse of Pythagoras theorem, triangle ABC is right angled. Is a right triangle, right angled at B. Okay, next one. Online students, use the emoji, raise your hand. Shreyas, very good. Lakshmi, good. Rajeshwari, good. Deepika, good. Priyasha and Shashmin, good. Sashmin, very good. If AB is equal to AC and BC square is equal to AC into DC, prove that BD is equal to DC. BD is equal to BC. The figure is given. The figure is a part of the question. So now you will have to prove that BD is equal to BC. BD is in which triangle? BD is in ABD and BD is in BDC also. Okay. Now where is BC? ABC. And also in DBC. Yeah. Okay. So now again, see, you'll have to choose the selection of triangles. You should make a smart choice. So here you go with triangle DBC, which has BC. This one which has BD, and this one which has BC. That is ABC. Go with ABC and DBC. Okay, now let me answer it and then one. So see here. So it's like this. BC of, okay, let me write the proportion first. Okay, so you can write this like BC by AC. You can bring DC also down, anything is equal to AC by BC. Is this correct? BC, I'm making a proportion. BC by AC is equal to, oh, not AC. Sorry, sir. What should I write? BC by AC is equal to DC by BC. Is this correct? Okay. Now, these two sides are of which triangle? And these two sides are of which triangle? BC and DC are of which triangle? BC and DC are of BDC. BDC. So let me write that here. BC of triangle BDC. BDC is equal to DC of triangle BDC. AC and BC are of which triangle? ABC. AC of triangle ABC. BC of triangle ABC. All right. Now see, this is a proportion. BC of this triangle by AC of the whole triangle is equal to DC of the small. Okay, I'll say small and big. I'll say small and big. There's one small triangle, one big triangle. So the side BC of the small triangle by the side AC of the big triangle. So which is the included angle? This is the included angle. BC by AC, this is the included angle. No, some of us did not watch that. See here. I'm doing it again. BC of the small triangle by AC of the big triangle. This is the common angle. You're seeing there now. Is equal to DC of the small triangle. DC of the small triangle by BC of the big triangle. So this is the common angle. So angle C is equal to angle C, common angle. So this makes SAS. For SAS, what you need? You need one proportion and the included angle should be equal. By SAS similarity criterion, the two triangles are similar. See, if similar was not given, from BC square is equal to AC into DC, you can make a proportion. Remember that. From a product like this, you can make a proportion. From BC square is equal to AC into DC, you can get a proportion because there are 4 line segments there. BC, BC, AC, DC. There are 4 line segments. So you can make a proportion from that. And that's what we did. That's exactly what we did here. And we analyzed the 2 triangles in which we find these sides. That's why I wrote like BDC, ABC, BDC, ABC, so that you understand where these line segments are found. Okay, now, and then while reading the line segments, we understood that C is the common angle. So angle C is equal to angle C, common angle. Okay, now next thing is how to name the triangles. How to name the triangles. You're done, keep them. Okay. Yeah, please. So what was that? C is the common angle. So like, see, you have this, right? BC by AC is equal to, I've told you know, right? CD by CB. So that BC, CD, BCD, AC, CB, ACB. So we are saturated at. Thank you. Class, we are finishing. So you remember, we write like this BC, CD, right? DC is CD. And then AC, BC, right? The CB. Okay, so BCD. So the similarity is like this. BCD is similar to ACB by SAS similarity criterion. By SAS similarity criterion. Now write the proportion. So did you understand what I told you here, children? What have I written here? To name it correctly. Huh? Ah, yeah, sure. No, see here, we have BC, right? And here we have DC. What's a common letter? Yeah, see. Which is the common letter? C. So I've written like BC, CD. So that I can name the triangle BCD. And the denominator also we have C common. AC, BC. C is common. So write it as AC and CB. Instead of BC, write it as CB. So ACB is the other triangle. So now what's the proportion you get? BC by AC is equal to, BC by AC is equal to, we'll write the required one, okay? Okay, fine. BC by AC is equal to CD by CB is equal to BD by AB. Now what is given? AB is equal to AC is given. AB is equal to AC. Where is AB? So you take this one and this one. BC by AC is equal to BD by AB. It's given that AB is equal to AC. See, this AB and AC, they're equal. So next line you can write BC by AB because AC and AB are equal. Is equal to BD by AB. So from this AB gets cancelled, BC is equal to BD. BC is equal to BD. See, after proving that the triangles are similar, write the proportion. Write the proportion. Now we don't need this. We've written everything. We don't need this. What is given? AB is equal to AC. So see here, AC and AB. So next step, what you do? This AB. Okay, what did I change? I changed AC to AB. So that gets cancelled. So you get the result BC is equal to BD. All right. So therefore, BC is equal to BD proved. Write down fast. Oh, I have one more to do. Don't leave. I said 2 more sums. We finished one more we have. Examination 3 hours, no, we said, so 2 hours, we started 2 to 5, 3 hours on examination time. So nobody can complain that. Done, children? Online students finished writing?
Yes,
Okay,
ma'am.
take us.
Yes,
Okay.
ma'am.
All right, very good. One more and we'll wind up the session for today. How do you prove that a quadrilateral is cyclic? What is the property? Yes. Online students, tell me, how do you prove that a quadrilateral is cyclic? I got the answer from one student in the class here. Okay, so we are given that AB is equal to AC and AD is equal to AE. So given this, we'll have to show that the points B, C, D, and E are concyclic. Concyclic meaning they lie on a circle. Here they don't lie on the circle, but it means that you can draw a circle passing through these 4 points B, C, D, and E. When we say that 4 points are concyclic, that means you can draw a circle passing through these 4 points B, C, E, and D. Okay. So to prove that these 4 points are concyclic, that means you should prove that the quadrilateral is a cyclic quadrilateral. And the property is in a cyclic quadrilateral, opposite angles are supplementary. So in this see, BCED is a quadrilateral that we can see. BCED is a quadrilateral. We can see that. So we have to prove that it is a cyclic quadrilateral. How do we prove that? By proving that one pair of opposite angles is supplementary. Then it is a cyclic quadrilateral. And if it is a cyclic quadrilateral, then its vertices are concyclic. Understand? Then its vertices are concyclic. Okay, so we have to prove that either B plus E is 180 or we'll have to prove, either we'll have to prove that B plus E is 180 or C plus D is 180. Yes. Okay. Write down, children. You were writing along with me, is it? Okay, you can leave. Come, show me a book and. Numbers in there, one in there.
1, 2, 3.
You started writing from here. So that means you're blindly copying. Following this blindly copying. Okay, let me finish it. So listen to me now, children. We are given that AB is equal to AC. We are given AB is equal to AC and AD is equal to AE. Subtracting these two, subtracting AB minus AD is equal to AC minus AE. Okay. When equals are subtracted from equals, the remainders are equal. Okay, so that Euclid's axiom we use. Okay, so now we have BD is equal to EC, that you understand. So BD is equal to EC. Now carefully write it so that you get a proportion. So now see here, you have this, no, AD is equal to AE you have. That's given. And now you got a new one. BD is equal to EC, you got a new one. See, on subtracting, you got a new one, right? I'm just erasing all this, 1 second. So see here. Yeah. We have two equalities in the question. We subtract and we get a new one, correct? Now we write this AD is equal to AE, which is given to us, and this new one which we got, BD is equal to EC. Now when you have see children, when you have A equal to B and C equal to D, there are 4 results which you can write. Listen to this. Very important. When you have A is equal to B and C equal to D, A plus C is equal to B plus D. Okay. Then A minus C is equal to B minus D. Then A into C is equal to B into D. And also A by C is equal to B by D. You can add the 2 equations. You can subtract the 2 equations. You can multiply the 2 equations. You can divide the 2 equations. We are doing the quotient. So AD by BD. It's like we have AD, A is equal to B, C is equal to D. So we are doing A by C is equal to B by D. So AD by BD is equal to AE by EC. And that proportion tells us by the converse of Thales theorem or the converse of basic proportionality theorem that DE is parallel to BC. Yes or no? Because of this proportion, AD by BD equal to AE by EC. From this proportion and from converse of Thales theorem or converse of basic proportionality theorem, DE is parallel to BC. DE is parallel to BC. Now, mark the, see now, if you don't know, mark this also as 4. If you don't know what to mark all the 4 angles, that's all, and use whatever you want. Now your question will be, how do I know that I should mark these angles? Mark all the 4 angles and use whichever you want. Okay, so now we start like this. Because the lines are parallel, DE and BC, co-interior angles are supplementary. Angle 1 plus 2 is 180. Co-interior angles are supplementary. 1 plus 2 is 180. But since AB is equal to AC, it's an isosceles triangle. It's an isosceles triangle. So the base angles are equal. Angle 1 is equal to angle 3. Angle 1 is equal to angle 3 because it's isosceles. So 1 plus 2 is 180 because co-interior angles are supplementary. But 1 is equal to 3. 1 and 3 are equal. Isosceles triangle property. So instead of what now, what should you substitute? You have 1 plus 2 is 180. 1 plus 2 is 180. You must get 2 plus 3 is 180. Opposite angle is supplementary. So carefully replace, that's all. Instead of 1, use 2 here in this one. In this one, sorry, instead of 1, use 3. Instead of 1, use 3. Because 1 and 3 are equal, no? 1 and 3 are equal. So instead of 1, use 3. So you'll get 3 plus 2 or 2 plus 3 is 180. Because 1 is equal to 3, instead of 1, use 3 here. So 3 plus 2 or 2 plus 3 is 180. So that means opposite angles, one pair of opposite angles is supplementary. Therefore, BCED is a cyclic quadrilateral and the points are concyclic. All right? All right, children? All right, children. So that's it for today's session. Thank you so much. You may leave the call, and I'm very happy that all the 6 of you stayed till the end of the meeting. Thank you so much, online students. You may leave the call, finish writing, and you may leave the call. Thank you. Thank you, children.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children.
Thank you, ma'am.
Thank you.